And the following exercises evaluate the triple integral over the bounded region. So let's take a look at number 203 here. And we look at the region E, and we see that our x is between a negative y and a y, which is just the variable y. We see y is between 0 and 1, which is just constants. And we see z, which is between a constant and an x and a y function. So the way I look at this is I always start with the bounds that have the most variables, because as I go through the process of integrating, those variables will lessen when the next variable comes up. Now you'll see what I mean after I set this up. It's a little difficult to explain completely. Sometimes you have to see it in order to understand what I'm completely saying here. So the first bound I'm going to start with is the z, because it is bounded by a function of xy. Oops. Okay, here we go. So the integral is going to go from 0 to 1 minus x to the fourth minus y to the fourth. And then we're talking about the function z here, and then that means I'm doing my dz first. Okay, now the next bound I'm going to use is the negative y to y, because that's another variable, and if we see the y's, those are just constants. And we always put the constants on the end if we have this sort of setup for our bounds. Normally, we have to come up with these all on our own. So in this problem, it's fine, but just remember that in general, that a lot of times I won't have a choice like this to even make. And then my y is going to be from 0 to 1. So my next one is going to be dx and then dy. All right, so let's run through this integral now. So we're going to do the integral of dz first, so again, from the inside out. So that's going to be the integral from 0 to 1 still, and the integral from negative y to y. So this is going to end up being 1/2 z squared. And it's going to be from, 0 to 1 minus x to the fourth minus y to the fourth. And then I'm going to have to do my dx next, and then my dy lastly. All right, so having this now, we'll have to plug in the upper bound minus the lower bound. Now, when I plug in the upper bound, I'm going to get a squared polynomial. And then when I do plug the bottom in, I'm going to get 0. So it's just going to be minus a 0. So let's just write that all in then, see what that means. So from 0 to 1, integral from negative y to y. And this is going to be a 1/2. And then this is going to be a 1 minus x to the fourth minus y to the fourth squared. And then, like I said, minus the 1/2 0 squared. So that's just 0. So I'm not going to worry about that. And that's going to be dx dy. So now what we can do here is we can actually square that out, and probably that would be the best thing to do. It's going to be awful, though, because we're going to end up with a lot of terms here. So now multiply through. Now go through this on your own. Make sure you're comfortable with it. Negative y to y. But we get 1/2 x to the eighth plus x to the fourth y to the fourth minus x to the fourth plus 1/2 y to the eighth minus y to the fourth plus 1/2. And we get dx dy. Now again, when I did that first integral, now notice this, I'm going to do x next. So when I plugged in that upper bound for this z function here, I ended up introducing more x's and y's, and that's why I did that first, because now since I'm doing dx, I'll be able to integrate with respect to x and get rid of those x variables in here. So that's the reason for that, if you didn't notice that from the beginning when I described it. That's what's really going on here, is I'm introducing this bound here, and then when I plug it in afterwards, it's going to introduce x's and y's into the function. And since I didn't integrate with respect to x yet, I have no issues, and I won't have an x left over in the end. So that's why I put that first. And notice I put the y second, and then notice when I integrate that now, I'm going to introduce y's into the function down here. And then I didn't do dy yet, so I'll be able to eliminate them once I get the y done. So that's the idea here. Okay, so let's move on then. Let's go further now. Now we're going to do this with respect to x now. So, oops, I won't have that bound anymore. So that 8 is going to be a 9, so that's going to be 1 over 18x to the 9th. And remember, it's with respect to x here, so the y is just a constant. So plus 1/5 x to the 5th, y to the 4th, and then minus 1/5 x to the 5th, and then plus 1 over 18. Oops, no, that's not true. Ooh, almost got me on that one. So 1/2 y to the 8th x, and then minus y to the 4th x, and then plus 1/2 x. And that's going to go from negative y to y. And then I'll still have to do my dy. So now, when I plug in the upper bound minus the lower bound, I'm not going to go through all of that computation here. So you might want to stop or pause the video and work it out. So I'm going to end up with 68 over 45 y to the 9th minus 12/5 y to the 5th plus y dy. Once it's all cleaned up, that's what I end up with. Excuse me. All right, so then we're going to do this last integral now, and that's going to be to the 10th here. All right, so that's going to be a 10. So that's going to be 34 over 225 y to the 10th minus 2/5 y to the 6th plus 1/2 y squared, and that's going to be from 0 to 1. So then we're going to get 34 over 225. When I plug in the 1 there, that's just going to be 34 over 225. And then for the second one, it's just going to be minus 2/5. And then for the third one, it's just going to be plus 1/2. And then I minus the lower bound, and I see I'm just going to get a bunch of zeros there. So that's what I end up with. So I'm not going to write it. And then this is going to be my answer. And when I add all those up, I get 113 over 450. So there's our answer for this triple integral here. And I think the big thing to take away from this is how should I organize my bounds? Now again, I could change bounds here, but again, I'm dealing with equations here, here, and then also here that I would have to take into account when changing bounds. So if I wanted to do like a y first, I would have to take this equation here and actually solve it for y, because this equation would be this equation right here. Z equals 1 minus x to the 4th minus y to the 4th. This would be a lot more difficult, though, because these are 4th powers to actually set it up that way. So this would honestly be the best way to do it. But again, you see the repercussions of that. And then I might have to change this around depending on what I pick next here. And these would be the other two equations, x equals negative y, and then x equals y. So all those bounds are equations for us that we have to take into account, especially with a problem like this when we're trying to, if we're trying to change bounds, the order in which we integrate, excuse me. All right, so there it is. So our answer is 113 over 450.